Following example is from April 15th lecture. Just in case if somebody looks at this and they go, hey, what was this again? Okay, so you see something like this, right? Let me make sure that was April 15th. Yeah, okay. So when you see something like this, right? The first thing you should all do, if you're really hung up on the modeling in terms of how to break it down, is to do this. Obviously, you're not going to have a printer and you're not going to print out anything. But if you did have a piece of paper, or if you're looking at this, right, you should just scribble like this. That's not what you're looking at, right? Before you even touch the bottom half, you should be completing the first half, and there should be no jumping around. There should be no, oh, but what if? No, none of that. You just kind of scratch it all out and you ignore it. I guess obviously the easiest way to do this is if you're looking at a computer screen or your phone, right? Only scroll in or zoom in to the point where you can only see the first part. Now, when we look at the three components, right? Let's label them 1, 2, and 3. One, two, and 3, right? We should be using the finance, predominantly the finance problems, to be able to identify each of these problems. So what every one of you should be able to do by now, and if not, again, it's okay, right? Is you should be able to tell me what kind of problem the first, second, and third are. And I'll start with number 1, right? Number 1 here in purple, right? This isn't anything formally we learned in class. It's to make sure you realize. So again, this is part 1. Right? This is nothing that was learned in class. When you have this written out, revenue generated by 5 times the number of employees, it's supposed to be teaching you linear stuff, right? The concept is linear. And it's supposed to realize that it's just a number times a variable, right? That's, again, previous prior knowledge that you're supposed to have already. So again, 5 times x, for example, or 5 times e, right? Where e equals total number of employees. So that one's fine. So again, we're not looking at the bottom, right? It's all scribbled out. You all should be able to identify the next 2 bullets or components, right? What are they?
For the second bullet, is it the future you're trying to find? Are you trying to find the recurring payment?
Okay, and how do we know that? Thank you for answering.
Because it's saying monthly deposit and you have a goal.
Good. Okay, so then that means that you should not write everything down, right? You should just go, what is that, light blue? You should, any one of you should, anyone that's learning from this, right? You should be going, oh, it's my future value, and I'm solving for R, right? Identify each component before you even start plugging stuff in, because then it gets very overwhelming, because then you won't have any kind of roadmap per se to go from whatever to whatever. And as long as you take this approach, you should be good every time. Yeah, you may have a hiccup here or there, but the good news is that however I write it, it will always be in a logical or even the same sense that we've done in class, okay? So there's that. What I was gonna ask, what I was gonna say. Okay, cool, that's fine, that's good. And then what about the third bullet?
Are you trying to find the present value?
So how do you know it's a present value? So the previous problem, sorry, I know I asked a question and I kept on talking. So I was just gonna finish. The previous problem, it was good because you go, oh yeah, you knew this was future value because there's a goal. This time around though, I heard hesitation, and that's again fine. Why do you think it's a present value? What's the key word there?
That you have a lease.
Right, and that's the key every time. So here, goal is kind of, you know what? No, I'm not gonna put a box. I'm gonna put a circle. Actually, no, I'll put quotation marks. And goal is more or less a future sense anyway, right? There are times where it could be present, but then again, contextually, you have to be told in such a way that it makes sense, right? It can't just be out of the blue or whatnot. However, both classes, whether this semester, my semesters in the past, as well as my semesters in the future, when you see lease, you know for sure it is always, always. Always a present value problem. Present value problem. The difference though is now which variable are we solving for? And you only have two choices, right? If you happen to be looking at the formula sheet, right? It's the, I believe the third row down, and it's either the, what am I trying to say? It's either the third or fourth column, okay? So you wanna ask yourself, well, which one is it?
The fourth column.
Right, and the reason is that here they tell you that you have a present value. This $250,000, that's what you are loaned. That's what your lease is worth, right? You can't all of a sudden tell me that, oh, yeah, it's a present value problem and we're solving for the present value, right? Unless you're telling me that your lease to your office equates to having $250,000 payments every month, which is ridiculously high for a piece of property, right? So at this point, right, what is that, number two, number three? You should have part two. And part three, you should be able to see these details and then put them in their respective equations and get the answers, right? So what I'll do now is I'll leave this up for about, not too long. Let's see, it's 9:20, almost 9:22 right now. I'll leave this up for about 3 minutes or so, maybe 2 minutes. Give everyone a chance that's practicing to write it down, and then I'm going to move down and then write it down as well. And you're supposed to be doing this for both the second and third bullet, just if anyone's curious. Right, set them up, get your calculator out, whip them out, make sure it's all done and everything. Actually, let me see if I have this written out already. Yeah, okay, good. Almost time for the stock market to open, which is nice.
Do you want us to give the answer when you finish?
No, it's fine. I will write it down in a moment. Just pulling it up right now. Just give me a quick moment. Normally I would ask for people to say out the answer, but then I don't want to accident here, actually have to ask to repeat and stuff like that. But I just want to make sure that everyone at least has something written down so that at least they're familiar with the process. But yeah, sorry, I just got caught up doing something really quick and checking for you guys. All right. So part 2 here, there's part 1. I'll circle the part that we need. So part 2, your setup should have looked like this. I'll write out the formula too. So yes, future value. What is that? 1 plus I to the n minus 1 equals 1 million. 0.0452 1, nope, did that wrong. Double parentheses, 1 plus 1, 0, 4, 5, 2, minus 1, close. So again, these are all compound monthly, 360. And then that's equal to 137,773. All right. And then part 3, right, is now the recurring payment for the present value, which basically looks almost the same. Just remember the denominator is a little bit different. 1 plus I to the negative n. So that one comes out to be 250,000,000.05. 1 minus 1 plus 0.85. And again, our numbers divided by 12 to the negative, what is that, 240. And it's equal to 1649.89. Okay, so what's supposed to translate is that once you figure it out, once you've taken the time to figure out what the pieces are, right? Like we did up here with the 1, 2, and 3, then you want to move over and get those respective numbers, right? What I was saying in class prior was that sometimes people don't solve for the numbers immediately, and then they get the, they use the symbols instead. So if you recall, this one is equal to the recurring payment for future value, and this is the recurring payment for present value. Do you have to use that? No. If you take the time to crank out the numbers anyway, then you don't have to worry about it. It's just, it's good. It's there, it's what needs to be, and then that's pretty much it. In the meantime, though, for those that say, you know what, I'm more of a numbers person, I'm not enjoying this dig, but at least I know what's going on and I can crank out the answers, then you probably want to do it this way, and then you circle, like I have in orange, each of those things. Now comes the construction of the model, right? And the model comprises of these 3 pieces. Another step that might help you is that once you now see the numbers in front of you, or maybe you could have even done it up here in the written form, you need to identify, and I'll write it down here. So this is your base model as I've been describing. Base being your first one, right? With more to come depending on the follow-up questions. You need to identify of these 3 circles, what makes you money and what costs you money. So who wants to take a stab at that? Or another way to reword the question is that if you're going into a month, right, and you have all these numbers, what are you going to put in your, I mean, I'm not sure if anyone uses an Excel spreadsheet, but or a checkbook to balance their checking account, if they still do that. But which of those techniques would you use, right, to go, oh yeah, this is what I would do, or this is how I would do? Which of these would I plug into my balancing checkbook? Anyone here still use a checkbook? Balancing checkbook such that they'll go, oh, okay, yeah, this part is a plus part, this part is a minus part, plus, minus, so on and so forth.
I guess part 1's the positive.
Yep, so this makes you money here, makes money. So if it makes money, it has to go in front, right?
Mm-hmm.
Models are always money coming in minus things that cost money. And you can always, anything that makes money, you can always put it at the front. So this becomes 5E. Yep, that's good. What are the other two components?
Does it matter what order they come in?
Nope, not really.
I guess the two numbers would just be subtracting off of the 5e.
So this would be costing you money, and this would be costing you money. People like to put it in the order that they solve or the order that they're constructed or presented in the problem, but that doesn't matter to me. All right, and that's it, right? This box translates to this question right here. How would you represent the above monthly situation? That basically means make me the model, right? I'm not looking for anything fancy. It's just, hey, this is what it is, and this is what I'm asking for. And it's just a nice way to pull it all together, if you will. So there's that, okay? Only when what we did right now together, and by we, I mean mostly you guys, right? Then you would start attacking these questions that I have now crossed out in purple. And you would only refer to the stuff above, which we just finished, only if the question asks you to. And even then, I don't do that very often, okay? So then what questions do we have about recognizing these pieces and arriving at this such that we have a model? Because that's all modeling is, right? It's finding different methods of things that can make you money. So I'll write this up here as well, right? Other ways that make you money. They could be linear, which we just did, right? It could be cost, revenue, profit. Cost, rev, profit, that's also linear, right? It could be exponential. And it can be a constant. It could also be a summation. So when you hear summation, it's not that the whole problem is a summation, it is one part, one component is a summation, right? So it doesn't all of a sudden make the entire problem difficult or anything. It's just saying that, hey, you got something that's making you money and it's a summation, right? The whole lease and goals to have in the future, right? That still holds, right? That doesn't change. Yeah, there may be multiple parts, but these, another way I said it for the class yesterday was that when you're looking at all those bullets, right? Those are equivalent to your exam, right? Each bullet, it's its own question. And just because they're all listed together doesn't mean that they all, I mean, here, they all relate to one another when you make the model, obviously. But when you're trying to solve for the number in each individual case, those are all standalone, right? Having the goal over 30 years has nothing to do with you mixing the 20 years in the lease, right? So sure, it's all kind of congealed together, or it looks like they're all kind of merging, if you will. They all stand alone, right? So the problem should be attacked alone. And that's why we do it like this. So what questions do we, go ahead, sorry.
Yeah, the list that you just did in green.
Uh-huh.
How does that, is it just affecting bullet 1?
Those are the types of bullet ones you can have. Things that can make you money.
Okay.
Right? So, oops, sorry, go ahead.
That's okay. After we
like, what would that look like? What would that look like?
Yeah.
Okay. So cost, revenue, profit. What is a cost revenue? We can actually say right now, what does a cost, revenue, profit normally entail? How do you know, and this is for everyone, right? Not just, how do we know when a cost, revenue, profit problem is one, if you will? What are its key components? Make sure no one's typing out the problems, the answers. No, they're not. Okay. right? So then if you don't know, that was January 31st lecture. Let me reference that here too. Jan 31st lecture. Okay. Now, obviously, I'm not going to ask you to flip to that right now on the notebook and look for it. Normally I would, but how do you know it's a cost revenue profit? Or how do you know when a problem just simply looks like that? What is provided? What is given to you?
You're given 2 sets of points.
There you go, right?
Some kind of numbers.
Right. So I'm going to make a third page right now because the second page is going to be answering the questions here. But I'm going to say add a page. So my question to you was, how do we identify a cost revenue profit problem? And the answer actually, let me do it this way. Question, and the answer is that there must be 2 points given, right? Something like x1, y1, and x2, y2. Now remember, they're not going to be written out like that, right? They're going to be written out in sentences and you have to identify which is which, right? And the hint is that normally if it's cost revenue profit, the, what do you call it? What am I trying to say? The money portion is normally the one that has the Y values, right? So that's that. But the thing is, you want to also say and. This is very critical. Actually, I should write it in capital ands. And the phrase each blank produced can be sold for so many numbers of dollars, right? Because that gives you the revenue function. So that's how you know that it's cost revenue profit, because they have to give you not only the 2 points, but they also give you that. When you look back at this problem now, let me push this page aside. Exponential. How do you know when it's an exponential problem? When the expression has a what? Starts with a P. Some kind of
Percentage.
Try again. What does exponential mean?
Profit.
Simpler. This has to have either an exponent / power, right? Like x squared, 4 to the x, right? Just something to do with powers. Okay, a constant is just a number, 500, 600, 700. 800, whatever. And the summation was, well, that was from which lecture it was, I believe 2 weeks ago, if not 1 week ago. Okay. So all I'm trying to have people recognize is that there are things that make you money. What are they? In this case, it's the purple 5 times a variable, right? You generate revenue. And I will always tell you it's going to be generating revenue, right? I'm not going to give you a random problem and all of a sudden say, oh, this one was actually supposed to be making you money, even though it didn't say generating revenue, right? The purpose is not to trick you. It's just to show you that, okay, cool, that's what's happening. And you go from there. Now, what other questions do we have for components that could potentially come up as well as constructing your base model?
Is there example, which lecture did we do like one of the other listed part one?
Of you mean of anything that's making you money?
Yeah.
Let's see. I think all of them actually. You can start from the April 15th lecture going forward and try to identify which they are. In fact, you know what? All of them. So to answer your question, you can see varieties of them in the Google Doc. So this, if you go pull up the Google Doc that I have created so that people don't have to type as much, this problem that you're reading right now is for the first page or on page 1, and it's number 2. So obviously you're not going to try that. But any of the other ones, they have different methods of ways of making money. So I always try to make something different so people can see a variety of them. So if you move, if anyone for that matter moves forward and tries to do some of the modeling problems, you'll see that there are many different ways of how I interpret or how I provided a way to make money. If you want to know specific lectures, they're basically the last 3 lectures we had. So not including this past Wednesday, but the ones before. So that should have been April 15th, 17th, 22nd, 24th. And then your homework as well. Your homework has different ones as well. All right, what other questions on this portion, right? In terms of understanding components as well as, excuse me, as well as constructing your base model. Because after that, then we'll talk about the follow-up questions. Give you a moment to think. All right. If not, let's move on to the follow-up questions right now and have a take a look at those and see if we can interpret these correctly. Now, the follow-up questions, they can range to anything in the sense that they could be questions that ask you to calculate things. They can be questions that ask you to change the model, right? Or manipulate it, right? Or the questions can be theoretical, where it requires a little bit more thinking and less writing, right? And there's no, if you will, structure or template that tells you, hey, this is what this is. It's just a matter of reading it and recognizing what the problems are asking. So if I unscribble this purple now, right? Now we can work on this, right? If you read number 1, right, it says, what is the outcome of the model if you have 10,000 employees? So they're telling you have 10,000 employees, right? Let me write this out again. You got 3 kinds of questions. They are calculating, manipulating, and theoretical. So those 3, right? 1, 2, and 3. I'll number them again. 1. Actually, no, I'll put it underneath. This is 1. This is 2. This is 3. Right? So when you read number 1 right here, what is the outcome of the model if you have 10,000 employees? Does that sound like a 1 kind of question, a 2 kind of question, or a 3? Well, actually, you know what? No. We're at too many numbers here. Let's call it A, B, C. A, B, or C kind. So you asked for 10,000 employees, and they're asking you, hey, what's the outcome? What do you think you do there?
Did you plug in the 10,000 where E is?
It is. And now which of those kind of questions is that? A, B, or C?
A.
A, right? So you go, this is an A type, and you plug in 10,000 and you get your answer, right? You guys can do that. The answer is also on that April 15th lecture too. Now, when you go part B, it says, assuming your model stays the same for the second month, except now your income is generated by 10 times the number of employees. And I ask you, how does the model change? What is happening? What is happening to our base model? So this is, you could also think of this as the first month's model, right? First month's model. So now all of a sudden, question 1, let me just write this really quick. Question 1. E is equal to 10,000. Log in. Excellent. Question 2. I'm telling you right now that there's a second month's model. Second month's model. And all that has changed, according to the written statement, is that your income is generated by 10 times the number of employees. So now, if you have your base model here, and you're looking at your parts that were used / constructed, whatever, previously, what happens now?
Can you scroll back up to question 2?
Sure.
Thanks.
Mm-hmm.
It's the part C, is theoretical.
So you can think of it as either, I would take either. I would call this either a B or C type. Because what happens? If you change, let me use green, if your income is generated by now 10 times the number of employees, and you look at the base model, what changes here in the orange rectangle?
So the 5E.
Change it to
50.
So then if you change it to 50, right, is that now 10 times the number of employees, or is that 50 times the number of employees now? Right? The first suggestion was 50E. Does that represent 10 times the number of employees now, or 50 times the number of employees?
Oh, I think I misunderstood. I thought we were like, I don't know.
That's okay. I'll scroll
I'm
back up here.
confused from like how we just answered the first question, and
So
I
the first question,
feel like
so
50,000.
hold on.
Okay.
Hold on. Okay. So the first question, you just told me to plug in 10,000 to E, right?
Yeah.
Did you do all of that calculation yet?
Yeah, and I got 50,000 minus the.
No, I mean, like, give me the entire number.
Oh.
The entire number. Yeah. Not just plug in. Give me the entire answer.
50,000 minus 1377.73 minus 1649.89.
Right, and what's that answer?
Oh, I didn't know. Wait, this solves. Okay. I thought we were just creating a new base model.
That's number 2, not number 1.
Oh, okay.
Right, again, these questions are individual of one another as well. So when you're when you're calculating, right, you're calculating for only question number 1. They don't bleed into one another, if you will, unless, again, otherwise stated. But as of right now, there's no bleeding.
Okay. I got 46,972.38.
Right, that's the answer that's in the notes from that day as well. So that's correct. And that's a positive outcome, right?
Mm.
Profit was made. Profit was made. Okay, now question 2. Oops. Question 2 is asking, oh, come on. There we go. Question number 2 is asking, so if it helps, maybe just cross this out. We're done. Boom. Okay, now question number 2 is a B or C type. So there's some kind of either manipulation of your model, basically creating the second month's model, as you said, or you could think of it as theoretical because it's kind of like changing things without too much calculations. So all of a sudden it says your income is now generated by 10 times the number of employees. Is that affecting part 1, 2, or 3? Which of these 3 things were income? And if you look, I wrote it in black and red, so you should only be looking at one option. I'm sorry, there's only one option available. And what is that option?
Part 1.
Part 1, 2, or 3? Part 1, right? So that means you're not, number 2 follow-up question is asking you to change part 1. So when you have question 2 written out now, and I'm asking for the second month's model, perhaps it helps people to realize that this isn't changing, so it comes down again. Minus 1, 3, 7, 7, 7, 3. This isn't changing, so it comes back down again. Minus 1, 6, 4, 9, 89. Right? These are not changing because of 2 reasons. 1, they are recurring payments, so they happen every month, right? That's what it says here. You have a goal with monthly deposits. You have a lease you don't pay one time, you pay over time. And then when you read the follow-up question number 2, it says, your income is generated by 10 times the number of employees. How does your model change? There's no mention of the lease or the monthly payments. So you know that only part 1 is being changed. So then if you look at your base model here in the orange rectangle on top, and I already said these two follow, how does the 5e change? Right, if the first part it said, where is it? Generated by 5 times the number of employees, but now it says your income is generated by 10 times the number of employees.
Oh, we're just changing 5 to 10.
Correct. Right, so now it's just 10e. Right, so the numbers aren't multiplying, right? Otherwise, I would have said, oh, you make 50 times the number of employees. Or it would have said, I guess what's another way to get 50? I don't think there's another way I could think of. Yeah, I would have either said, you take your previous revenue and then it makes 10 times as much now, right? Then that will tell you like, oh, take the other thing and multiply by 10. Or I would have said just written out word, I'm sorry, 50, right? Here, I just said 10 times the number of employees. You went from 5 to 10, right? Mm-hmm. And the best way to think of it is that, say you're making like, say $20 an hour, right? And all of a sudden they say, hey, you're gonna make double your hourly wage now. Well, most of us, we can go like, oh, cool, we make now $40 an hour, okay? But if someone said, oh, you make $20 an hour, you know what? I'm gonna make your hourly wage $100 an hour. You're not gonna go, oh, so I make $2,000 an hour now? Right? You're not gonna multiply unnecessarily. You're gonna, your base is $20 an hour, and all of a sudden I come up to you and I go, hey, you're gonna make $100 an hour now. You make $100 an hour now. You don't make $20 an hour. You don't make 20 times 100. You don't make 2 times 100. You don't make 100 times 2 or anything of that nature. So that's what's happening here. You were told at first that you've made 5 times the number of employees, and now all of a sudden I change it on you and I said you make 10 times the number of employees, right? So number of employees is still a variable of E, and it's just a matter of recognizing that you replace the 5 for 10, okay? So let's do this right here. All right, now for the third question, it says, so we're done here, so you can cross this out now. That's done. Okay, now for the third question right there, it says, suppose for the third month, no changes occur, right? So that means you have the same model from the second month, sorry. Not only for, but from the second month. Okay, so what that means. But now it says you have an additional one-time expense. One-time expense. Okay, you need to make $500,000 with a single deposit at 7% compounded quarterly over 40 years. So when you read this sentence in the pink parentheses, what kind of problem is that?
It's the future value. And you're trying to find the recurring payment?
So here's the thing. When you read that, is there any notion of you putting money away multiple times?
No.
And you've already answered your own question. Yep, it isn't. It's one time. So if it's one time, what row should you be looking at when it tells you that it's compound quarterly? So that means there's a CP and there's some kind of profit, goal to be made.
That's the first row. And
which formula?
The second column?
Second column, yep, exactly. So now, for question number 3, they're telling you 2 things. They're asking for 2 things, really. But you would complete it by doing these 2 things together. So they're asking for the third month's model. And any additions? To the model. But when you answer that second bullet, you inadvertently answer the second bullet. I mean the first bullet, blah, 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 sorry. So these are actually a joint venture. So the way that works is that we have now established that since it is one time, right, and compound quarterly, right, that you should be using this first row with the second equation or second column, right? So I want people that are doing this, there's information, I'll leave it up there so you can see it, and take a moment to calculate that and tell me what the answer is, please. See these two low points right here? I just bought 2 shares of it right now at that low point. See, so that's, here it was, what's it, 38, 37, and I got it at 39.52, so it's kind of fluctuating right now. Hopefully it doesn't go lower during the day. And I gotta buy more. I just bought 2. I need to put more money in the account if I'm gonna play more. They're almost out. Dividends to reinvest. The moment it goes up $1, I should sell them. Like, oh, I made money. Before the drop, $69. Yeah, but that was like back in January. Johnson & Johnson is still too expensive to buy. It's at 11. Hold on. Inovio's at $11. No, I want to buy it under 10. And then Gilead is at 79. I don't know. They've been on the upward trend ever since. In March, it dipped as low as 70. But then the highest it's been right now is 83, 84. It's too risky. Abbott's still well above where it started, so it's at 90 right now. Do we get what this P number is for number 3?
Yeah.
Okay, go ahead.
249,800.49.
Let me double check that. Wait, did I write this right? Oh, I see. I gotta double check it. I changed the problem last time. Compound quarterly, so that should be.
Oh, I think I messed up.
That's okay. I'm gonna double check it right now. 1 plus 0.07 divided. It's more than, no, it's less than 200,000.
Okay.
If anyone needs to see it, it should be like this: 500,000, 1 plus 0.07 over 4 raised to the 4 times 4 is 16. That's what you guys should have written out.
Yeah, I forgot to multiply the quarterly with the 40.
Oh, okay.
So about 31,150 and
Yep, 37 rounded. Okay, so now what happens is that we take, that is answering this, any additions to the model. So we need this piece now, and it's gonna go right at the end here. So now what we do is to answer the third month's model, which is gonna be down here, right? You take this entire orange rectangle and you repeat it, right? I didn't say any changes to this. There is also no changes saying that you're gonna revert back to the 5 because it's a progression. You go from month to month. These are the monthly payments that we had prior. And then now we can tack on this here because this is an additional expense for the third month that we have to worry about. 31, 150, 37. So what happens is that when we answer the second bullet down here, which is this 31,000, so these two are connected right here, that allows us to provide the third month's model, which is this right now. And then I know the question didn't ask for it, but if there was a fourth month's model, you would repeat everything except for the last one because the last one was a one-time payment. Does that make sense?
Mm-hmm.
Perfect. So yeah, that's basically how you should approach every model. The only difference is that now, when you attack them, you know you're going to see some familiar things such as lease and goals and linear and one-time payments, and then sometimes you have to decipher when it's a cost revenue profit or summation or something like that. But the good news is that when you do have to tell those components apart, I always write it the same way. So there will be no confusion or no mix-up as to, oh, well, did he really mean this? No, I only mean one thing. It's whatever the thing is, right?
Mm-hmm.
So that's that. What are the questions on this problem? Oh, by the way, I should note here as well that this question, this problem is almost the same as example 2 on April 15th lecture. There was a little difference there, the last part. That's why it took me a moment to figure out what was going on. But yeah, it's pretty much good to go. All right. What are the questions on this modeling problem? This is a very vanilla case. It's very Nothing's too out of whack, if you will. Nothing too difficult. I wouldn't say it's the most basic, but it's
Afraid
it's good.
of, because like what we just did this and I feel like really good about it and I could
Okay.
definitely problem again.
Okay.
But I fear that like when the exam comes, there
Okay.
is going to be something that does throw me off.
Well, what are you?
I'm not
Well,
really
okay.
sure like if it's just like the wording will be different or
No, it wouldn't. It wouldn't. Right? If I ask for a lease, I'm gonna write the lease the same exact way. If I'm asked for a goal, the goal is gonna be written the same exact way. If it's gonna be a one-time payment, it's gonna be written, and I'm gonna signify that's a one-time payment. So if you feel good here, that's great. What I would try to do is redo the homeworks.
mm-hmm.
And then what will happen is that when we reconvene on Wednesday, you can go like, hey, I did homework 1 again, and I was able to get this is what starts to happen when students start getting the hang of it. They'll go, hey, I redid this problem or whatever problem from the notes, or it doesn't even matter. You just did a problem. And instead of saying, I don't know where to start, the better verbiage when I know students are getting the hang of it is that I was able to get all the components except for this one.
Mm-hmm.
Then we can really hone in to identify what is it that you fear that's going to be thrown off for you. If you already know all the possibilities, then you have nothing to fear. So if you feel good about this in terms of breaking it down, in terms of going it over together, that's awesome. Now you just need to practice, because what will happen is that, will there be another problem that looks exactly the same way? No. Similar? Absolutely. And then you just need to figure out what those different components are. And if you want immediate feedback in the sense that it's like, oh my goodness, I'm stuck right now because I'm working on it right now, you just shoot me an email and then I'll reply.
Okay.
Mm-hmm. Otherwise, it's going to be just pretty much, I'm going to pull another lecture problem from the previous ones and go, okay, you do this now type of thing, and then we'll work on it together, which we could do. We have another hour. And if anyone else is having a question too, please chime in.
From last, I believe it was last Friday lecture, there was a symbol that was used. I don't know if it was just meant like sum.
Yeah, the sigma notation.
Okay.
This one. Right? So
Yeah.
that one, that refers to, did you watch a YouTube video on sigma notation that I made?
I didn't.
Okay, you probably should watch that, right?
Okay.
And so for sigma notation, I'll write that here, sigma notation. Sometimes you'll see it as, because the video is only 7 minutes long. It's not a lecture. It's like an actually produced video. But I'll start on talking about it right now. Sigma notation, you should do 2 things. You should watch my video on YouTube and subscribe, right? Watch YouTube video and subscribe.
The video where somebody kept throwing the water bottles at you was funny.
Exactly. Perfect. Thanks, Michael. So it's supposed to show you that when you do a summation, it always increases by how many at a time. How many times did they throw the water bottle at me? And how many water bottles did they throw at a time? Only
3.
3 in total, but when they gave me one, it was how many at a time?
1.
Right, exactly. So it cranks up 1 at a time. So you want to refer to, what is it? What lecture is this? April 22nd. So I'm going to write April 22nd and then reference April 22nd lecture. Okay, but I'll still reference it here. So let me move this question back up. Okay, so this is all having to do with number 1. And then now sigma notation. Actually, you know what? I'm going to copy this. And then put it in our next question page. So the question was, sigma notation, and my answer is so the YouTube video is supposed to give you an idea of what it is in the most basic form, so you know what the heck we're talking about. And then the lecture is April 22nd, but we'll talk a little bit about here. So when you have, I'm gonna write this on the third page now. So summation here. So if I give you the numbers 5, 3, 1, 0, and 4, and ask for the summation there, what would you do basically?
So you just get 13.
Yeah, you just took these numbers and then you added them together, right? Not only did you rewrite them down, 3, 1, 0, and 4, throw plus signs in there. So 8, 12, and 13, and that's your answer. Awesome. So that's the most fundamental way that we learn it. But what happens when you have a sum that's a pattern? So then what if I tell you to find the sum right? Obviously this answer, we can figure it out. That's 5 and 9 and 10 and 15, right? But what you want to notice is what is the increase when you go from each number plus 1?
Plus 1.
Plus 1, right? So normally at one point in time in the life of people learning, depending on how far you got in math, if you ran into summations, people say, hey, look for the sequences or look for the series, where those are common words that they teach about this type of thing. They'll say, look for the sequences or the series to find the pattern, right? Well, it turns out if you have a pattern like this, you can write it in a summation. The summation says that if you have, this is just a label right here, right? If you're wondering what do the variables stand for, it's in the April 22nd lecture. But this is a label. There are no variables to solve for here. And then this, nope, different color. This is an algebraic expression, and it can be any kind of expression. Here, it's a very simple one. It's just a variable. So the way it works is that if you have, say we want to use this same exact example, but put it in sigma notation, it would say, hey, you start at 1 and you go to 5 and you plug in a number at a time. This is equal to what? Well, you start at 1 and you see that I is equal to 1. That means every time you see an I, you plug in a 1. And then since there's no other details to this algebraic expression, You check if it's 5 yet, and the answer is no. And then you cycle back down here, and you start the next number. And as Michael said, you increase by 1 at a time. So it's not no longer I equals 1, but it's now I equals 2. And then since it's a summation, right, you put a plus sign in between them. So now you double check, you do the same thing again. You go, oh, okay, I is equal to 2 now. We go to our algebraic expression. What do we have? We have a 2 now. That's all there is. You check if it's 5 yet. The answer is no, you're not on 5, you're just on number 2. And you finish it with a addition sign. And then now you go from 2 to I equals 3. You plug in a 3, you check if it's 3, the answer is no. And basically you keep on going until it's 5, and then once it's 5, it's done. So the sigma notation allows you to, instead of having to write out 1, 2, 3, 4, 5 like that, I can write it out with just this representation, and it means the same thing. And again, that representation for 15 is to say that you go from 1 to 5 when you plug in only a single variable, right? Then what happens is that between the YouTube and the April 22nd lecture, I show other variations of that. And then I also show you what does it look like when you have a problem that talks about the summation, like the growth and the initial sharing and stuff like that. But if you're not familiar with the summation, I would highly suggest watching the video and seeing the April 22nd lecture, understand how the summation works, and then we can finally talk about summation problems. Otherwise, if you jump right into the summation problem, then you're kind of like, well, I don't know where this came from. I don't know where that came from. And so on and so forth. So that's a good way to start it. I would strongly encourage to watch the video for a more lively way of going about it. And also April 22nd, read either a combination of read over or watch the lecture up until that point, and then we can really figure it out from there. But for the summation, for what it is here, again, it's just like the regular summation here. Instead of mixed numbers, here we have an ordering. Does that make sense, at least, of how to interpret this sigma notation? Right? To say sigma is I equals I to 5 for I is the same thing as writing out 1, 2, 3, 4, 5. And both of those are equivalent to 15. That's why all these, now let me use a different color. That's why all this, they all mean the same thing. 1, 2, 3, 4, 5 added together is 15. 15 is also the answer of the summation. And this summation is equal to listing out 1, 2, 3, 4, 5 added up together. So all those 3 details, right? Here, call this A, B, and C, right? They're all equal to one another. But normally when people are learning summations for the first time, right? They see the summation first, write out the numbers that interpret it, and then they normally get the sum at the end. That's normally how they go. This happens first. So you have to identify it. Second, in terms of writing out the numbers. And then actually third, adding up the numbers. I just wrote it again at the end here just so that it was cleaner to see instead of all my colored scribble there. Colored squiggles. All right. What other questions?
I mean, for me, that's all I really had. I think now I just have to like go practice on my own.
Mm-hmm. Yeah, I'll send you an email again, so don't sweat that. But anyone else, you know, take a moment, flip through your notebook, think of something, think of nothing, think of anything that you may ask. And then if you're not doing anything today, I wouldn't practice right away after this, right? I would take a break, as I always say, right? You just already had an hour and a half of math and everything. If it was familiar to you and you're like, oh yeah, I got a handle of this, and some parts were a little hazy, but I got it pretty good, that's great. That means you just need to practice a little bit more. If you were here and you just kind of wanted to passively listen, but you understood everything, that's even better. That means that you should definitely take a break and then try again either later tonight or first thing tomorrow morning. I mean, obviously not right when you wake up, but give yourself some, rest time and then go at it again. If you're really insistent to look at it again before the day's end, right? I would look at it again tonight, not right before you sleep, but like an hour or two before you plan on sleeping. So maybe like 6 or 7 or something like that. And then practice, whether it's a combination of previous homework, you redo the lectures problem, right? I mean, on the PDFs, you can see them written out already, but try to recopy down the wording and not look at the answers and try to do it for yourself. Or you can even try the review problems or whatnot. Remember, if you look at Wednesday's lecture, at the end of lecture, I listed the content in terms of what's going to be on the final, right? And I've also omitted some things too. So if you want to look at the first and second exams, you can do that too. Remember, the first exam is posted there as a downloadable PDF, and the second exam, you can't see the second exam as in like retake it, but what you can do is if you go to your grade section in Blackboard and you go to the second exam, one of your classmates showed me this. She said that I can't see it because I have the faculty view, but if you click on the grade itself, you should be able to open it up and see all the answers as well. And then you can retry those problems as well. All right. So there's nothing else. I'm not going to end the class immediately here in terms of ending the, what do you call it? The Zoom meeting, right? I'll let it sit for 5 to 10 minutes, see if anybody lingers in or they're trying to think or something. But if you're good to go, you're good to go. The last thing I just wanted to say was that this video and Wednesday's video, it's processing right now on my computer. So I just need to trim it and then upload it. And then what will happen is by the end of another hour or so, no, 2 hours, another 2 hours or so, what will happen is that those videos will be on our playlist as well. Remember, we're section 806. So the playlist will have those details in there. All right. But otherwise, enjoy the rest of your day. Hopefully you don't have another lecture after this. And you're free to go. And then if you want to stick around, just in case you might have a question that pops up, I'm going to keep this open for until the entire class exits the Zoom meeting. And even after then, I'll give another 10 minutes just in case someone pops back in.